Hello everybody. Today let us look at the binomial theorem, which is a continuation of the last lesson on combinatorics, combinations and permutations. Okay, so now, binomial theorem, basically, this is when you have x plus y, and you take it to any power, any integer power, and actually any power in general, any real power, or rational, if nothing else, and let's just say power n. And can you write it out as a expanded expression, right? Like let's say x to the n, right? Because we start with x times x times x n times if we take the x all the time from each of these, right? And so what does it really equal to, and how do we find that? So here goes. First, let's explain. Let's write out what does it mean to the n power. Well, that means that you're multiplying the thing, which is x plus y, by itself n times, right? That's what it means to take it to some power. So to the first, to the second, now cubed, right? To the third, and then you have maybe to the fourth, and you go on and on and on and on, and you do this n times, n minus 1, and then finally the nth term, okay? And that's what this means. And of course we have basically one of these, two of these, three of these, four of these, and it can go to any n minus 1, and finally n, okay, nth term. And that's the idea that I just want to bring out there, that you have n of these. Okay, so anyway, what does it equal to? How do we expand it? Let's go to the basics of looking at what does it mean. First of all, let me ask you this. What does it mean to the 0th power? Let's just make sure, let's get that straight. Why is something to the 0th power, besides, the indeterminate form 0 to the 0? So don't do that. But what does it mean, let's say, 1 to the 0th, 3 to the 0th? Why is it going to equal to, let's see, what? So here goes. Let's just quickly show, let me kind of quickly show you this. So let's say 2 to the 0th. Let's take a number 2. It's easier for us to look at. And then maybe, let me lower this just a little bit. Okay? And let's just do powers of 2. So we have, okay, well, 2 to the first, right? That's just a 2, 1, 2, right? And what is 2 squared? What is 2 to the second? Well, everybody knows that, right? That's 2 times 2 is 4. Okay, what's 2 cubed? It's not 6, right? It's 8, right? 2 times 2 times 2. Basically, 2 times 4 is 8. And basically, you're doubling every time you're going, let's say 2 to the 4th, you're doubling the 8, becoming a 16. And then 2 to the 5th is a, what? 32, and actually 2 to the 10th is a 1024. 2 to the 20th is larger than what? Than a million, because it's 1024 squared. But let me show you another thing. What about negative powers? What does it mean 2 to the negative 1? Well, that means flipping the 2, right? Reciprocal. That's the reciprocal, 1 over 2. Okay, what does it mean 2 to the negative 2 power? Well, that means you flip it and you square it. Okay, the negative always does the reciprocation, right? So negative power. So 1 over what's 2 squared? 4. And what is 2 to the negative third? Let's just do one more there. That's 1 over 2 cubed, which is 1 over an 8. Okay, so 1 over this is that. Okay. Now, what is it going to be? What is this number right here going to equal to? Well, what can it not be? What can it be? Well, think about it. If I go from here to here, I'm dividing by what? A half, by 2, right? 32 to 16, divide by 2. Divide by another 2, divide by another 2, divide by another 2. Oh, what happens if I divide 2 by 2? Well, that's a 1. Okay. Well, is it going to make sense to divide 2 by 2 get a 1? Is it, what about from the other direction? Let's multiply by 2. 2 eighths is 1 fourth. 2 fourths is 1 half. What is 2 halves? Oh, it is indeed 1. Cool. So 2 to the 0th, and any number in general will be to the 0th power, is 1. So let me just begin by doing this. I'm going to say, okay, well, that basically leads us to understand that x plus y to the 0th power, because it's something not 0, is equal to 1. Okay. What is x plus y to the 1st power? Well, that's just, copy x plus y. Right? And what about x plus y squared? That's just, we know that. That's a binomial, kind of the first binomial thing we think about, which is x squared plus 2xy plus y squared. If you really want to look at that, right, what you do is you do the first terms. Let's do FOIL method. First terms outer, inner, last. Okay. And you do, really, it's what? X plus y times x plus y. Okay. That's what it means squaring. And then multiply the same thing by the same thing. First term's x is x squared. Outer terms x times y. Okay, x plus y, xy I mean. And then inner terms yx, right? And finally, last terms y squared, y times y. And that means what? That's actually x squared plus how many xy's? Well, xy and yx are the same by commutative property of multiplication, right? 3 times 5 is 15. Similarly, 5 times 3 is 15. So anyway, we have two xy's really. This one and this one that are both xy. And so that's why we have x squared plus 2xy plus a y squared. And then if you go a little bit further, let's say x plus y cubed. Okay, and so I kind of, know this already, but if I didn't, I could just multiply x plus y times this, and I get, and again, this is a slow way, really, x cubed plus a 3x squared y plus a 3xy squared plus a y cubed. And then x plus y to the fourth, imagine you don't know what it is, it's called the binomial theorem. You're like, whoa, I don't want to multiply all this out by, I call it multiply everything by everything possible. Instead of, and add it up, right? Instead of going the FOIL method, well, you can't do FOIL method when there's like a middle term. Like, what are you going to do with this? Like, x plus y, and then this is x squared plus 2xy plus y squared, right? Like, basically x squared and then another one. That's what this is, right? And so what happens is, well, that's a middle term. There's no, FOIL doesn't have an m even, right? So it doesn't work always, this FOIL method. I always teach my students basically what? Multiply everything by everything possible. Every possible combination for the left, some number term on the right, some term, multiply those and add all the possibilities up. Okay, anyway, and we can see what x plus y to the fourth is. There's a pattern, but that pattern is basically what the binomial theorem is about. Let's go ahead and now look at something here. Look at the triangle. Look at the coefficients, the numbers. What is a coefficient? What's 1? Well, 1 is 1. This is actually going to be called the Pascal's triangle. It's going to be really cool. Watch this. Pascal's triangle. Okay. I'm going to make it a little neater here. Pascal's triangle. Really cool triangle. Okay. It's what it does. It helps a lot. So look, put a 1 here. That's kind of like the, whatever to the, that's a 1 up there. And then what about 1x plus 1y? Forget the x and the y. What are the coefficients? 1 and 1. And what about this? Look at this. 1x squared plus a 2xy. Look at this. 1x squared plus a 2xy plus a what? 1y squared. 1, 2, 1 are coefficients, right? Okay, put them underneath. 1, 2, 1. Now look, what happens is if you always do the ones like that, and then, like this, and let's make it kind of neat here. Let's say like that, and like that. Okay, and look, what happens is you always add numbers. The number below and between the two is some of these. So look, this is 1 plus 2 is 3. Just like this was, look, 1 plus 1 is a 2, right? And what's a 2 plus a 3? That's a 1 is a 3. And we have a 1, 3, 3, 1 row. There we are. 1 x cubed, 3 x squared y, 3, 1 y cubed, right? So that's where, you see where that is going to help us a little bit, right? And so 1 plus 3 here is 4. 3 plus 3 is 6. 3 plus 1 is 4. Oh, 1 plus 4 is 5. 4 plus 6 is 10, and 6 plus 4 is 10, and 4 plus 1 is 5. And guess what? We can continue doing this. We can say, okay, 1, 6, 15. You see that? 20, 15, 6, and 1. And you continue doing that again and again and again. Every row you go on. And what's the point of this? Well, first of all, let me ask you this. What's the sum? Row sum. Let's do this. So that helps a little bit. That's kind of, we'll see why that is later, but watch. What's 1 adding up to? 1. What's 1 plus 1? 2. What's 1 plus 2 plus 1? Well, that's what? That's 4. Calculate that, right? And what's 1 plus 3? 4 plus 3, 7 plus 1. Okay, that's 8. Oh, what do you think the next term is going to be? Look, 1 plus 4 is a 5, plus 6, 11, plus a 5, another 5 there. Oh, 16. And this is, yes, it's going to be 32, and yes, this is going to be 64 if you add them all up. Yeah. This is actually 2 to the 0th. This is 2 to the 1st. This is 2 to the 2nd. We did these above a little bit, right? A little bit above when I started telling you about why this is equal to 1. And so 2 to the 4th, 2 to the 5th, 2 to the 6th, and yes, believe it or not, the next one's 2 to the 7th, which is 128, and so on and so forth. So what happens is, look, this is reminiscent of the coefficients of x plus y to the 0th, right? And this is x plus y. So x plus y to the 0th gives you that, basically. Just coefficient-wise. And then, of course, x and y, x, y terms, we have to figure that out also. But this gives you the 1x plus 1y, and this gives you x plus y squared gives you x squared plus a 2xy plus a 1y squared. What about x plus y cubed? That's going to give you 1x cubed plus a 3x squared y plus 3xy squared plus a y cubed, 1y cubed, just like we had above, and so on and so forth. So now, as a guess, let's say hypothesis basically, like a guess it basically kind of thing, guess that x plus y to the fourth is equal to, right, what happens? We have a 1, write these out, 4, right, plus, and then plus a 6 there, and plus a 4, and plus a 1. Let's see, so those are coefficients. Now what? Is a 1 what? 1x to the fourth. And 4x, you go down in the powers, x cubed y. That's kind of, we haven't done that yet, but that's what's going on. X now squared, but y goes up, y squared. X goes down to x to the just first power x, and y goes up to y cubed, and finally y to the fourth. And that's the guess, and that's actually correct. That's going to be what x plus y to the fourth is. And we did that quickly, right? In fact, look above there, x plus y to the fifth will be, let me kind of quickly write this out, x to the fifth plus, you see how quickly I do this? This is basically using the binomial theorem that we haven't completely proven, but at least we can see what the idea of that is, right? And then we have this, and then this x squared y cubed plus a what? 5x y to the fourth plus a y to the fifth. And so similarly for x to the x plus y to the sixth, and even going further, right? X plus y to the 10th, whatever, right? So, but now why? Here's a question I have. Why? Well, let me give you kind of the combinatorics answer to that. Okay. So look, let's do this x plus y times x plus y times x plus y times x plus y times x plus y, and let's just keep it there. Let's do 5. Okay? Now equals 2. Well, what we're going to do is this. Okay. Let's think about it this way. From every one of these, right? These expressions, x plus y, these binomial expressions, x plus y, x plus y, x plus y, x plus y. What happens? Every time you multiply, at the very end, what happens? Let's say you did x times an x, times an x, times an x, times an x. That's going to be the x to the fifth. But what if you did x and then here you choose the y, and then maybe an x, an x, an x? That's x to the fourth y. What if you did 2 y's instead of, and then you'd only have 3 x's, right? Because you only have 5 terms possible, right? You pick one from each of these and you multiply it out. That's what's going on. And so what's really happening is it's equal to some amount of just all x's, x to the fifth, right? Some amount of some x to the fourth y. If you had 4 x's and 1 y, you would have some amount of what? X cubed, 3 x's and just 2 y's, because you have to have a total of 5, right? And then there are 5 terms to multiply it. And then what about this? X squared, 2 x's, and then 1, y cubed. And maybe later we'd have, not maybe, but for sure we'd have x y to the fourth. You see, that's what's going on. And then of course y, that's y to the fifth. Cool, right? So in other words, why do we have exactly 1 here? There's only one way to do that, right? You choose 1 x, 1 y. You choose x from each of those. In other words, actually, you know what we're doing? We're choosing. Let's go to the y's. How come I have y to the fifth and I have 1 there? Remember the 1 right there, the reminiscent of this. We did have a 1 right there, and that's coming from right here also. Remember 1, 5, 10, 10, 5, 1. Look at this. Here goes. Let me show you. 1, 5, 10, 10. 5, 1. You see that? 1 y to the fifth. So anyway, y1, y1, y to the fifth. If you remember combinations, this is big. Combinations. Recall that choosing m from n objects in how many ways? In C, n choose m, or n choose m, like this written, ways, right? And what is this equal to? With n choose m equaling to n factorial over m factorial n minus m factorial. So in other words, what we can do, let's just kind of do an example like 5 choose 2. And what is 5 choose 2? It's like, let's say I choose 2 y's, and the rest are 2 y's, and the rest are going to be, of course, the 3 x's. But you choose 2 of them to be y's from the 5 possibilities. And so that's what's going to happen. Watch this. 5 factorial, which is 5 times 4 times 3 times 2 times 1. Okay, over 2 factorial, 3. 5 minus what? 5 minus 2 is a 3, right? I'm going to write 5 minus 2 factorial, 3 factorial. This is what? 5 times 4 times 3 times 2 times 1. By definition factorial, you just go down, 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 multiplying. And this is 2 times 1, and this is what? What's 5 minus 2? 3. 3 times 2 times 1. These go away. 5 times 4, 20 over 2. Oh, 10. Guess what? This right here is the right here, what we put right over here, a 3y. How many y's did I choose? 2, right? So right here, I'll put a 10. Get it? And that's the 10 right there. These are actually the choosing 2 from 5. Yes. So instead of me, let me erase this for a moment. Well, we know this is this is a 10, but look, what's going to happen is this is actually 5 choose 2. And what about how many y's are we choosing here? 3. 5 choose 3. How many y's are here? 5 choose 4. 5 choose 5. 5 y's, all of them. You have to choose them all. How many y's? Just 5 choose 1. How many x's? X's to the 5, so y's are 0. 5 choose 0. Let's keep it that way. Now, you can also do 5 choose y. You can do x's, and 5 choose 5, 5 choose 4. Why is it the same thing? Think about it. 5 choose 3 will be equal to 5 choose 2, because all it is the reverse of, look, 5 factorial over not 2 factorial, but 3 factorial, and the other one is 2 factorial, right? They add up to 5. So you just flip these around. M factorial, n minus m factorial, you now have n minus m factorial and m factorial. And it does the same deal, same job. So it's again going to be equal to 10 again. Okay? Symmetric, right? Symmetric. Okay? That's cool, right? Okay. So now, let's just compute all those coefficients. Let's actually see what's going on. And I'll tell you, anything choose 0 by definition. Okay, so definition, or, by really, there's a reason for it also. Like, it makes sense in many ways to do this. That's why mathematicians choose it to be the case. 0 factorial is equal to 1. Okay? Just remember that. Okay? So now, what about 5 choose, let's just do this, 5 choose 0. Well, that's 5 factorial over 0 factorial. What's 5 minus 0? 5 factorial. Okay, that's just going to cancel out to what? 1 over 1. This is a 1, remember. So it's 1. There we go. The first one's a 1. We get it right here. Put a 1 in there. And then next to the fourth y, well, that's 5 choose 1. Remember, that would be the coefficient for that, because you have to, how many ways are there to get that where you have the x, and then y? Because maybe you're choosing the y from one location. Maybe you choose y from the other location. You only have to choose it one time. And so that's why it's going to be 5. You could choose it from one of the 5. But basically, look, it's 5 factorial over 1 factorial and then 4 factorial, right? 5 minus 1. And that's equal to, of course, 5 times 4 times 3 times 2 times 1 over 1 times 4 times 3 times 2 times 1. Everything cancels besides the 5 equals 5. Woohoo, we have the 5. And so similarly, this will also be what? 5 choose 3 is a 10. We just did that. 5 choose 4. Let's do 5 choose 4. Let's practice a little bit. 5 choose 4. We already did the 5 choose 2 and 3. 5 choose 4 is 5 factorial over 4 factorial and 1 factorial, right? Very similarly, 5. And 5 choose 5. Think about this. Why is that going to be 1? Because 5 factorial over 5 factorial, but now that's a 0 factorial, right? 5 minus 5. And that's just a 1 over 1. Okay, that's a 1. And so that's why we have these numbers 10, 1, 5, 10, 10, 5, 1. But now you see the reasoning. It's really how many times do you choose y, let's say, if we can focus on the y, from the number total possible, right? Maybe you have 0 y's here, right? So we're using 0. Maybe you have 1 y here, so you use 1, right? 1 y, what are the first is 1. Let me kind of circle that. Squared, what happens? By the way, this is what? This is y to the 0th. Keep that in mind. Anything to the 0th is still a 1. You could put it there if you like. And then what about, let me kind of use another color here 1 second. That's going to help us a little bit, I think. So this is actually just an addition. That says y to the 0th. You circle the 0. Y to the 1. You circle the 1. Y to the 2, right? And then that's a 2. Let me kind of circle these. And then y to the 3. So you're choosing 5 choose 3. Y to the 4. 5 choose 4, y to the 5, 5 choose 5, y choose 5 choose 5, right? Okay, so cool. So what is really going on? What's the general pattern? Okay, when we have, here it goes, we're basically getting the formula at the very end of it. X plus y to the n, any n, okay? And especially for now, let's consider an integer, or positive natural number, basically, okay? Positive integer. What happens? You definitely have, look at this, n choose 0. You have no y's. Let's talk about the y's. Okay, you can do the x's as well and choose n, but like let's do. So we have no y's and just x to the 5th, x to the n, right? All of them, all these n are x's. Then you have, of course, you can put it y to the 0th if you like. It's just 1. That's why you have x. This is 1 and this is 1 right away. This is x to the n, right? We knew that. X to the 5th, x to the 6th, whatever it is that you take into the power. The first term is that x to the whatever power, right? And then we go on with, let's choose. We have x to the, now n minus 1, we have 1 less x and 1 more y, right? That's what's going on, y to the first. And you're choosing n now 1 y from that combination, right? And then you go on with maybe choosing 2 y's, and of course you'll have 2 less x's, so minus 2, and then y is y squared. Finally, you go on and on and on, and you choose, let's say, all but 1 y. So n and then n minus 1, and you have x to the just first power, but y to the n minus 1, right? And what's the very end? That's going to be y to the n, right? What that's going to be is plus a, let's choose all of them to be y's, and choose n of them. X now to the 0th, there's no x's left, to the, basically just a 1, y to the n, and we know that ends with y to the n at the very end. This is actually 1, this is 1, so it's just going to be y to the n, okay? And so now, what is this actually, another way to write it? Well, we can write it as a summation notation, okay, as follows. Let's go from I, a lot of times we use I, equals, let's go from 0 to n. If you think about it, there are actually n plus 1 terms. Not just 1, 2, 3, 4, 5, 6, 7, da 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 n, but 0, 1, 2, 3, 4, 5, 6, 7, da 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 n. And you see, like, look at this. For example, here, 5, we took the 5th power, but look, how many terms do we have? 1, 2, 3, 4, 5, and 6, right? So that's 6 numbers, not 6 terms, not 5. And so 4, you have actually 5 terms. So here we have from 0 to n, what can we do? We can run it as follows. N choose the I, right? The 0, so that's, we're going to choose first 0, then we're going to choose 1 y, then we'll choose 2 y's. And then how many x's? We have x, but now if we're choosing y and y we choose I times. X we have less from n by I, right? Because we have chosen the y's instead of them being x's. And that is exactly, from going all the way to n, this is exactly what the binomial theorem tells us. The result is that, and we proved it kind of in a sense of conceptually, in a combinatorics and combination sense, but this is the binomial theorem. So let me write it one more time for us. Let's do an example and we'll write it one more time. Let's do, and you can use the Pascal's triangle, by the way, right? So what we can do is let's do this quickly here with an example such as x plus y to the n power, okay? And that's equal to, well, let's go, what I do is I can sometimes kind of think about the Pascal's triangle because it gives you the combinations, or I can quickly do them in my head. But look, it's a 1, 7, 21, 35, 35, 21, 7, and 1, right? So let's use these numbers, okay? So what's going to happen is, basically 7 choose, if you write it out, 7 choose 0, x to the 7th, y to the 0th, plus a 7 choose 1. Let's actually just go slowly here for a second. X to the 6th, y to the 1st, plus a 7 choose 2, x to this. This is how you really would do this if you're kind of slow, kind of going a little slower, just starting with using the binomial theorem. But this is really what's going on, and this is exactly, you can do the Pascal's triangle to speed the process up, right? And so on and so forth. And so we finally get to 7 choose 7, right? Of the x to the 0th, now y to the 7th. It's just going to be basically y to the 7th. So let me just quickly do this as, that's a 1, so x to the 7th, y to the 0th goes away, so this is a 1 also, right? So x to the 7th plus 7, x to the 6th, y, plus, what was that one? 21, right? 21, 7 choose 2 is 21. We saw that in Pascal's triangle. You could try this, okay? 21, x to the 5th, y to the 4th, y squared. And then we have 35, remember that? 35, x to the 4th, y cubed. And then again, a symmetry argument, 35, it goes just down the same number, coefficients, right? Y to the 4th, plus a 21x squared y to the 5th, plus a 7xy to the 6th, and plus a y to the 7th. And that's what's going on. That's actually a result. That's correct. Finally, we'll write again this result in black. We'll write this binomial theorem one more time at the very end. But let me show you one more thing. How about I ask you this question here? Watch this. What if I said, hey, you know, what is the sum of the coefficients? Sum of coefficients. And that's how we basically did a row sum, remember? And we got the 2 to the power something. Right? Remember that? How we did above the Pascal's triangle? We're like, oh, that's 1, that's a 2, 1 plus 1, 1 plus 2 plus 1 is a... So look, what is this? Look, 1 plus a 7 plus a 21 plus a 35 plus another 35 plus another 21, another 7 and another 1. How do you do this quickly? I mean, we can do these numbers, but what if you had a bigger one? N is bigger. So for n choose 7, we expect to get 128. And that's 2 to the 7th. And why is that? And we already looked at that a little bit. Because coefficients is when, look, this is just a 1, this is just a 1, this is just a 1. When it's just, you're adding up just the coefficients and all the other ones are just 1. How do you make them 1? You let x set, or let x equal y equal 1. Cool? And so now instead of x plus y to the 7th, we will have what? We will have 1 plus 1 to the 7th. Okay, and that's what? That's 2 to the 7th, and that's what's really happening. Cool, right? I think that's an interesting thing for some of us. And so finally, let's just finish this up with a little, again, just to remember, do you remember this result or not? Can we do it one more time? Just write the result, and what it is it's x plus y to the n, this is binomial theorem, is equal to the summation. Let's do summation notation. Okay. From I equals 0 to n, we have n plus 1 terms, and then we're going to do n choose I, x to the I, and then y 2, or let's do even x to the n minus I, right? We're going to usually start with the big X, and then y to the I. Okay, and that is the result. We'll put it in a box, make it neat looking, okay, and we'll call this, let's do this like a cool box here. Let's like a really cool box, right? We'll call this our result, which is the binomial theorem. And so you think there's nothing else, you're wrong. There's something called a trinomial, right? And so this is something, you know, you can always do x plus y plus z, and so on and so forth, and the same idea will hold. Okay? Similar idea will hold. It's a little trickier. Right? So hopefully you enjoy this lesson and have a great remainder of your day.